Hello, everyone. Thank you for joining. This is a Virtual Cloud Network Level 200 course. In this course, we are going to talk about some advanced Virtual Cloud Network functionalities. The prerequisite for this course is the Level 100 course for Virtual Cloud Network. In this course, we'll just build up on the concepts that you learned in the previous course uh, and some advanced functionalities like Service Gateway, through which you can access the services like object storage without going over the internet. Another feature on the route table is having a private IP as your route target. And then if you want to have peering established between virtual cloud networks, whether it's a local VCN pairing, meaning within the same region, or it's a remote VCN pairing across different regions. At the end, we'll have two sections on one section on edge security and the other one on best practices of virtual cloud network. All right, so moving forward, a service gateway enables your virtual cloud network to access public Oracle Cloud Infrastructure services such as object storage, but without exposing the VCN to the public internet. No internet gateway is required. The resources in the virtual cloud network can be private subnet and use only private IP addresses. The traffic from the virtual cloud network to object storage travels over the Oracle Cloud Infrastructure network fabric and never traverses the internet. If we talk about the use cases, one of the very common use cases is that you want to back up database systems in your virtual cloud network to object storage, which has a public endpoint. Now, without the service gateway, your VCN must have an internet gateway to access the public endpoints of the object storage. The database systems must have the public IP addresses and be in a public subnet with access to the internet. Or the other way can be that you can set up a NAT in your VCN and access the public endpoints via the NAT. With Service Gateway, no internet gateway is required or no NAT is required on your virtual cloud network for your database system backup. The database systems can be in a private subnet and have only private IP addresses. The backup traffic is then routed through the service gateway. And additionally, you can also set up IAM policies, the identity and access management policies, that restrict access to the bucket only from the VCN of your choice or the private subnet of your choice or with a specific CIDR as well. Earlier, if you wanted to get to the object storage, you need to be in a public subnet. So if you have in your instances in the public subnet and they need to have a public IP, have a connection directly with the internet gateway to get to the public endpoints of object storage. If you have your instances in the private subnet, the only option from private subnet instances to get to object storage was through a use of a NAT gateway. Afterwards, with the service gateway feature, you can have your public instances in your public subnet. They can have public IPs and access the internet using the internet gateway. And you can have your private instances like database systems in your private subnet with no public IP or access from the public internet. And they can access the public endpoints of object storage via the service gateway. And once again, when you access the public endpoints of service gateway or the object storage, your traffic never traverses over the internet. It takes the backbone, internal backbone of Oracle network. All right, so moving forward on the management of service gateway, you control routing in your VCN at the subnet level. So you can specify which subnets in your virtual cloud network use a service gateway. And right now, since the only service available in the service gateway is the object storage, but moving forward as we have more services part of the service gateway and they are enabled with the service gateway, you can specify for each subnet you can specify that which service the service gateway is for. So for instance, one subnet can be for the object storage and another subnet can be for a totally different service. A service gateway can be used only by the resources in the gateway's own VCN. So, for instance, if your VCN is paired with another, the resources in the other VCN would not be able to access the service gateway. Also, if your resources in your on-premises network are connected to the service gateway via either Fast Connect or IPsec VPN, those resources cannot use the service gateway as well. Although in case of Fast Connect, you can use something like Fast Connect public pairing to access your public endpoints of the object storage. Currently, object storage is the first service which is available with the service gateway. Secondly, when you create the service gateway, in order to enable the traffic access to the object storage, you need to specifically open up route rules in your route table and open up security risk rules in your security list as well. So, for instance, the route table which is associated with your subnet, you have to create a specific route rule enabling traffic for the target, which is the service gateway. In case of security list, you have to specifically open a service gateway security list rule that allows the traffic to and fro from the service gateway. You can create both stateless or stateful rules for the service gateway. Service gateway is automatically only attached to just one VCN of your choice. And when you create the service gateway, by default, all the traffic is allowed. But you can also specifically block all traffic through that service gateway. If you block all the traffic through that service gateway, even if you have specific route rules or security risk rules that allow that traffic, the traffic will not pass the service gateway. This is a one place where you can block all traffic through your service gateway. Currently, one of the things that we have seen is that the service gateway doesn't support the OS update, so you cannot get to the YUM repositories via the service gateway. For instance, if your database is in a private subnet and you need to update your OS, in that case, it would if you just have a service gateway, this would not work. But in the this is coming up in the feature, but in the interim, you can use a NAT gateway. All right. So moving forward, normally, as we have mentioned previously when we were discussing the route tables in lesson 100, Oracle uses a given subnet's route table only for traffic with the destination IP address outside the VCN. So typically, you'll set up either you'll create route rules for your target would be either a dynamic routing gateway or an internet gateway. But in some cases, there are instances that you want to route the traffic to a destination inside the VCN for all your outgoing traffic. In that case, you can use this feature as private IP as route target, which basically provides you an ability to set up private IP within your instance as your target for all the destination outside. So we have to note one thing, that using this feature, your destination IP address has to be something external to the VCN. So what are some of the reasons or some of the top use cases? You can implement a virtual network function such as a firewall or intrusion detection that filters outgoing traffic from instances. Secondly, you can also create or manage an overlay network on the VCN, which basically lets you run container orchestration workloads like your own Kubernetes network or Mesos or any of the container orchestration workloads. All right, so let's just basically go through a basic setup. So, for instance, you have a private subnet and a public subnet. Your private subnet has a private instances and is only connected to through your DRG to your uh, customer data center, to your own data center. And you have public subnets where you have public instances and you are connected to the internet using the internet gateway. For instances using this feature, what you can do is that for all the outgoing traffic from your private instances can go through a firewall and then basically go toward the internet. And to do that, using your route table within your virtual cloud network, you can define route rules such as these. So you have a specific route rule for your customer premises, like which goes through the dynamic routing gateway, and then all the outgoing traffic over the internet basically routes to the firewall instance which is present in the public subnet. Next, we will talk about VCN pairing. So VCN peering is the process of connecting multiple virtual cloud networks. It basically allows you to enable connectivity between the resources in different virtual cloud networks. And once you have connected the different virtual cloud networks through the VCN peering, the traffic does not traverse internet, and you do not require any public IPs, or you don't need to set up a NAT gateway to access each of the resources. It actually goes over Oracle's backbone to access the virtual cloud network resources between each other. There are two different types of VCN peering available. You have the local VCN pairing, which means that the VCNs which are part of the same region. So if you are existing in Ashburn, and if both of your VCNs are in the same region, that would be known as local VCN pairing. And remote VCN pairing is across region. So if your VCNs are existing in different regions across, for instance, in Phoenix and Ashburn, and you want to peer those virtual cloud networks, that would be part of the remote VCN pairing. So let's talk about local VCN pairing. So local VCN pairing is the process of connecting two virtual cloud networks within the same region so that their resources can communicate using the private IP addresses, and you don't need to route the traffic over the internet or your on premises. The VCNs can be in the same tenancy, or they can be in different tenancies as well. So when you are uh, peering to VCNs which are in the different tenancies, that's known as cross tenancy local peering. One other thing to notice over here is that you should not have overlapping IP addresses between your virtual cloud networks that you are trying to peer. Local peering gateway. So when you actually create the VCN pairing, there is a component known as local peering gateway that is needed to be created to set up the peering. Just like the internet gateway, it's a component of the virtual cloud network. Each VCN has its own local peering gateway, and there is a one-on-one peering relationship between the two VCNs which are paired together. So if you have a VCN which is paired with two different virtual cloud networks, you need to have two LPGs in that VCN so that each LPG can create its own one-on-one peering connection with the other LPG on the other virtual cloud network. So how do you create a local VCN peering? So the first is that you have, for instance, you have two different virtual cloud networks. One is, as shown in the figure over here, is virtual cloud network 1, and the other is named as VCN2. One has a different CIDR, so you have a 10/16 network for VCN1, and then 192.168/16 network for VCN2. One of the things that I mentioned in the previous slide was that your IP addresses should not be overlapping when you want to peer the two virtual cloud networks. So the first step is that you create a local peering gateway within each virtual cloud network. Next, you need to have specific IAM policies to establish a connection. So every user who has access to virtual cloud network doesn't get automatically access to create the LPG or create the peering connection. So you can specifically open up those policies for users to create that peering connection. Once the user has a specific IAM policies, then they can go ahead and can establish the connection across the two local peering gateway. Once the connection is established, the next step is to update the route tables and the security lists. So within each virtual cloud network, you have your own route tables for individual subnets and the security list. You need to edit and update the route table and security list for each subnet that you want to have a pairing relationship with the other virtual cloud network. Once you have updated the route table and security list, you can then go ahead and test the connectivity. For cross tenancy peering, the steps are kind of the same. The only difference would be that at step number 2, where you have to have specific IAM policies, you need to have that specific IAM policies with the other tenancies to create that connection. So let's talk about remote VCN pairing. So remote VCN pairing is the process of connecting two VCNs in different regions but under the same tenancy. And such kind of pairing connection then allows the virtual cloud network resources to communicate using private IP addresses without routing the traffic over the internet. The traffic basically goes through over the OCI backbone network. Currently, the supported regions are Ashburn and Phoenix, and London and Frankfurt. All the other regions are currently on roadmap for general customers, but there are limited customers who can have remote peering connections across all the different regions. Again, for VCNs to be paired across, even in case of remote peering VCN, they must not have overlapping CIDRs. In case of a remote VCN pairing, you need to set up a dynamic routing gateway and create a remote peering connection. The traffic flow is from the virtual NIC of one VCN instance in one region to the local DRG, and then from one DRG to its PR DRG in the other region, and then from there onwards to the VCN or to the local subnet in that particular region. Remote VCN pairing is very common use case specifically for data replication across regions. So another important concept is the remote pairing connection. So remote pairing connection is the component you create on the dynamic routing gateway, which is attached to your VCN. The RPC's job is basically to act as a connection point for a remotely paired VCN. If you want to create more than one remote pairing connections, you need to create more RPCs, one RPC for each peering connection. So what are the steps to create VCN peering? So we can start with the same first basic environment where you have two different virtual cloud network environments in different regions. So for instance, you have a VCN with 10.0.0.0/16 network in region 1, which can be an Ashburn region. And in Phoenix region, you have another VCN with a non-overlapping IP address for your VCN, 192.168/16 network. The first step is where you already have a dynamic routing gateway within each region, and there is an attachment already done between the virtual cloud network and your dynamic routing gateway. Once the DRG and VCN are connected, from there onwards, you can go ahead and create the remote VCN pairing. To implement the remote VCN pairing, you need to have IAM policies which are required for pairing. In case of remote VCN pairing, there is a concept of an acceptor and a requester. So there is a requester IAM policy for the VCN who starts or requests the RPC connection, and then on the other hand, there has to be a acceptor IAM policy for the accepting compartment or a VCN to accept that RPC connection. Once you have the necessary required IAM policies, you can create the connection across the two dynamic routing gateways via the remote peering connection. Once the connection is established, the next steps are the same, that you have to edit your route tables and your security lists in your specific virtual cloud networks to forward the traffic to the other which VCN. For instance, in the current example, you have a VCN 1 10/16 network. Within its 10/16 network, there is a subnet A with 10/24 network, and it has a route table which specifically says that to get to 192.168/16 network, it needs to route the traffic to the DRG. And similarly, on the VCN2, there is a route table for subnet X, which says that to get to 10/16 network, it needs to go to DRG2. So once the connection is established and the route tables and security lists are created, you can go ahead and test your connectivity. So some of the important implications of VCN pairing, be it remote or local VCN pairing. From an IAM policies perspective, there are certain things that you can control using the identity and access management policy infrastructure. So you can control that who can subscribe your tenancy to a different region. So for instance, in case of creating a remote VCN pairing, you can control that. You can also control that who can create VCN pairing or establish VCN pairings, either the remote or local. So you can specifically authenticate for users who can establish the VCN pairings across different VCNs. And you can also manage route table and security list access to the users as well. So each user who has access to VCN, you can go give granular capabilities to users to only access the route tables or the security list. Once the pairing has been established, you can control the packet flow over the connection using the route tables. You can also control the packet flow using the security list. In fact, the best practice is that you should specifically open the security list for only the traffic that you want to enable over that particular connection. You also need to ensure that all inbound and outbound traffic within your VCN is intended and expected, and it is well defined. And similarly, if you are in a lot of cases, since when you create your VCN pairing, your overall VCN traffic can increase. So if you're concerned about the level of network traffic coming to your VCN, you can consider using stateless security rules in your security list. So this actually completes our section on the advanced functionalities of virtual cloud network. Next we will talk about security and some virtual appliances. So from a virtual cloud network perspective, there are a number of different features that you went through which are designed to meet your security requirements. Just to recap quickly, so you have public and private subnets where you can designate your some of your instances which are in private subnets, so they don't get any access, any public IPs to them. You have security lists where you can granularly control that what kind of traffic is allowed to your subnet. You can attach multiple security lists to individual subnets. You can have firewall rules on the instance on the operating system itself. You can have specifically designated firewall rules on the instance. On the gateway and route table side, you can attach specifically internet gateways to specific subnets, so you can control granularly that what subnet or what resources within your virtual cloud network have capability to the gateways. Either they are internet gateways or a dynamic routing gateway or local peering gateways for VCN peering and stuff. And then at the end, you have the IAM policies to really control who has access to the Oracle Cloud Infrastructure API and the console. However, we see a lot of situations where enterprise customers require some specialized security for their resources. So in that case, in the next couple of slides, we'll walk through some of the high-level architectures where you can have virtual appliances on your edge. So in the current architecture, you can see that we are using a FortiGate virtual firewall, and all of our traffic within the virtual cloud network passes through the FortiGate firewall before it hits the internet, and same path on the way coming back, it also goes through the firewall as well. The blog link is given over there, which actually gives detailed step how to set up a virtual firewall from FortiGate within Oracle Cloud Infrastructure. So from an architecture perspective, you can see that there is a public subnet within two different availability domains, and there are two instances of virtual FortiGate virtual firewall running inside the two availability domains. In front of them, it's a public load balancer. So all the traffic coming in load balanced across the two availability domains. From there onwards, there is a private load balancer, which distributes the traffic among your web or app tiers. So your application tier and your database tier all are present inside the private subnet. And for high availability, they are also distributed again around on the two availability domains within that region. and your private load balancer is basically load balancing the traffic across the multiple instances across the two availability domains. Within your database tier, you have a database setup, and then you have a data guard set up for high availability into a different availability domain as well. In the next example, we are talking about a VSRX, which can be used as a virtual firewall or a NAT device within your virtual cloud network. There is a link also provided, so you can go and see detailed steps how to set up a VSRX within OCI. So high level workflow is that in this case, we are using some additional features which allows you to create more than one virtual NICs for an instance, and you can create those virtual NICs in different subnets. So in this case, what we're doing is that we are creating a virtual cloud network with three different subnets. We set up a VSRX image within one subnet, and then can create additional virtual NICs in different subnets. We use the instance console connection to set up the VCRX, and once the VSRX setup is complete, from there onwards, you can create private instances and then forward all the traffic from the private instances using the private IP as route target feature, and make the destination as one of the VNICs of your VRSRX. In this way, all the traffic is then routed, all the external traffic destined for internet is routed through the firewall and then outside to the internet. This actually completes our today's lecture. Thank you for joining, everyone.